All right, in front of you are undeniable signs of life. And the reason that they are protected in this manner is because of fascia. And you have to look at fascia's role in mud fossilization. There's a complete video on it. But this is the material, the fascia, that protects the soft tissue underneath. And the skin, all the organs, bones, everything are coated with fascia, and that's what protects it in these wet environments. They say that soft tissues are not protected well in wet environments, and that is just totally wrong. David Attenborough understands this process and has a video on BBC called Mud Fossilization Perfectly Preserved. And he's the only one that I found that seems to understand these mud fossilization processes. And the process is that the creatures are completely compacted in fine anaerobic mud conditions, cold, completely deeply compacted, and they are virtually in a plastic bag of keratins, because the keratin fibers of your body is just like a fabric bag, and every organ is completely separated from every other organ, tendon, muscle, bone, organs, everything is completely encapsulated in its own fascia. And that is what protects them in these wet environments, because it's not water soluble. So they eventually begin to react nucleophilically and anaerobically with the percolated sediments, the percolated minerals that are in the wet moisture that's percolating down, and that is a polar silicate material, and it creates microelectric currents, and that is what the fossilization process of mud fossils is based on. And this fossilization, the currents were proven by the University of Alberta in Canada, and I have also simulated these same conditions and recreated a similar result. You see the video that I have on one of those orange boxes about polar silicates, electrofossilization, organic matter, and so forth. Now, the process is virtually identical to petrified trees. And the center of all of these, the surface creates a layer of physiology, they call it, so that it breaks away from the encapsulated mud along the planes of the surface, which is coated with materials that are not water soluble. Now, internally, the organic material inside of trees, as well as the things that we have here, becomes fossilized in a process of ionic invasion, nucleophilic invasion. But the bottom line is that the polar materials, the silicates, they're polar, and they move with electricity, and they invade the original material, which is soft tissue, and they create hard rock structures, virtually crystallized. And this is, I believe, the source of feldspar, and I have done those tests. So that's how this is happening. Now, here's some more undeniable signs of life. All right, this is a human cadaver lung. And if you look at it carefully, you're going to see that architecture here. It has that. It has this little investment flap at the bottom, a little triangle. It's invested at the top with a tab. And the natural airway that comes into the lung enters on the side here. Now, this is a fossilized lung. And that is the red investment flap at the bottom, which is that facial investment. That is the investment at the top, and that is what tags it at the top. This here, you may have a hard time seeing it. It's difficult to visualize, but there is a circular pattern here that is where the airway would have gone in. And this is the identical pattern on the lung, which I said, look at that architecture. And that is what a left lung would look like if it would happen to be human. I'm not saying it is, but it certainly could be. And that is being overlooked as nothing. This is another lung that exuded blood when it was cleaned. This is what came out of that lung when it first was cleaned. And when I say it's a lung, I say it's a lung because it has the architecture of a lung, and if also you look at it closely, you'll see that it has the lobes of the lung. If you can see those little circles. And of course those are those little red spots where all the blood ran out of. And there's a circular area there that goes in as well. Now, this is obviously quartz now. So that the process and has been removed of its fascia. And that right there is the lobes of the lung. And that's what I'm saying we just saw on this. Now, there's another thing that I'd like to show you, which is another undeniable sign of life, and it is on that head, and it is in this broken bone. Now that bone is broken, snapped off here. I don't know how long it would have been, but every time we find broken bones in the mud fossil process, the center has black and deep red staining, and I will show you that in the microscopic shot. And they're always coated with this same fascia, as well as this is coated completely encapsulated in that fascia. And that is a fibrous, very, very dense fibrous fascia. On the lungs specifically, it is much more dense. This is another unmistakable sign of life. The carbon stain on this pattern is what's called a carbon silhouette stain. It indicates that the bone underneath is that exact same architecture. And this even shows the veins and the arteries where they blew out on the side. Natural process of the death process has to be explained. This is a tuberosity from the end of a distal phalanges of some sort, and it's enormous. That is the tip of a finger. This, if you have to see the video on the little finger, this is a petrified finger, and I will show all the evidence, and it's been accepted as petrified finger. This is totally undeniable sign of life. It has to be looked at. These are the types of crystals that are created from living creatures, and this at one time was a living creature, and that's where the blood flowed. And if you look extremely carefully, you'll see the fluid that exuded out of there. It ran down underneath and puddled at the bottom. This would have been laying in this condition. And that, I believe, is garniferous. And I have also recreated this very similar result using chicken in electrofossilization with silicates. All right, you've seen about the black and the red stains, and this is the black and the red stains that I'm talking about, and there is no other explanation for that. None. Zero. No one can come up with any other explanation for these concentrations of these elements in these particular wound sites. They are only possible from life. The anatomical features of the head are identical. See the video on the head, and you'll understand that this was a living creature at one time. And this changes the way history is perceived, because I believe this guy has a cap on, and he's not just a human being that lived sometime long ago. He was part of a culture. This has to be taken seriously. It has to be investigated. Now, once again, I'm not claiming this is a human fingertip, but this is a gigantic fingertip of some sort, and the blood pattern holes are identical to a human. That's all I can say. Now, once again, this is that fingertip that, hold on a second, that I was showing before that had the blood holes in it and the carbon stain and all that stuff. That's it right here. And that came from that hand that you see right there. Now, I'm just telling you what I find. And it should be looked at because it is physical and it's something that's real. The fingertip that I was showing you is out there, and then I have more of them. And then this is the palm, and if you put your hand like that, you have this same structure that runs down the center of your palm, heading right out to the second finger, right there. Exact same thing. And you have the same structure that laps your hand. This is only up to here, and that's 36 inches wide. It's undeniable something was alive there, and I don't know what it was, but it sure looks like it could have even been a gigantic human. It has the same exact architecture. What I'm pointing out is what I see. I'm not making anything up. It's what is here. And it should be looked at.